Blast off. Okay, so we're going to talk about this for a second, so I'm going to leave this here for a minute. Oh, man. So, Rubik's Cubes, right? Ever popular.
My dad's amazing at them. Oh, yeah.
Hey, we got to try to get through 2 lessons today. Your homework is combined. We need to keep moving quickly. We want to get to some probability and statistics this year because that is really fun. Like, that's some fun math. Helps you understand the world around you. So, let's dive in. So, Rubik's Cube, right? Now, if you know how one of these is made, you're going to have to ignore what you know. So let's imagine that this is all just cubes all the way through. Now, if you actually know how these are made, and this is not a real Rubik's Cube, you can actually take the pieces off, and there's an object in the middle that lets it spin and do everything. But imagine we just have cubes all the way through. If I think about a 2x2, the easy kind of trainer Rubik's Cubes, how many sides do I have on any cube? Or faces? Because once we go to 3-dimensional shapes, we start talking about faces. So, yeah, moon 6, right? And how many squares are there on each side? 4, right? So if I look at this side, I can say this is a 2 by 2, which makes an area of 4. If we have 6 of those faces, we could easily figure out that the amount of stickers that would need to be on this for a 2 by 2, well, if we have 6 faces, each with 4 stickers, how many would that be? 24. And we would call each of those stickers a unit, and then we would square that because we're talking about area. So we're saying that each sticker is 1 wide and 1 long, because each of these is actually a sticker on here. You can take them off, you can swap them out with different things. So then if we move up to a 3x3, like I have here, how many stickers are on each face? 9, because 3 times 3 is 9. So I can figure out one face has an area of 9. How many faces? 6. So we can get 9 times 6. 54 units squared. What about, crazy ridiculous, 5 by 5? What would be the area of each face? 25. How many faces? So the surface area in total would be 150 units squared, or stickers squared, because 25 times 6 is not 125, it's 150. I heard some discrepancy out there. So, this is everything we're doing today. But cubes are really, really easy to work with because every face is identical. Not all prisms are cubes. So what are some other types of prisms that we could talk about? Andrew? Rectangular. Hexagonal or hexagonal. Triangular. Pentagonal. Ozzy? Octagonal or octagonal. Yeah. Hexagonal. Really, a cylinder can kind of be thought of as a prism because definition of a prism is it has a shape on the base and it has that same exact shape, congruent, same size, same shape on the other base or the other end. So we've got base and top, they're both circles. We could really kind of talk about a cylinder as a prism as well. So when we start diving into our surface area, we can say that this is our, hypothetically, we're now going to extend this to a new problem. We already said that the surface area of a 5 by 5 was 150, but that was with each block measuring 1. Well, if this is 5 feet long, what does each block here measure? No, if the whole edge is 5 feet. Yeah, each block is 1. So even though this is supposed to represent like a sculpture, this is the same as our Rubik's Cube. Because we have 5 wide, 5 tall, and it's a cube. So still, the area here for the total surface area would be the area we already found on our Rubik's Cube, but now we know our units. What's our units here? Feet. So now we're going to say feet squared. I did not mean to hit that. Now, 1 square foot of this sculpture. Hey, did I say come up here and grab shapes and play with them? So why are you? I didn't know I had to say things like that because I teach middle school. If each square foot takes 10 minutes. Now, who's going to Chicago? The bean. The bean is actually, I believe it's 177 pieces of sheet metal, all welded together and then polished to the point that you cannot see any seams. So if you're going to Chicago, I challenge you, try to find a seam on the bean. I can pretty much guarantee you won't, because it's been polished so well you can't see anything. So let's say we're going to try to polish this. Each square feet, because how polished it needs to be, takes 10 minutes. How do I figure out how long this is going to take, Ozzy?
Multiply that by 10.
I can take this and multiply it by 10. And we get 1,500 minutes.
That's a long time. Actually, how long is that? Divide by 6.
Ah, so if we want to talk about this in hours, we divide it by 60. Because there are 60 minutes in each hour. We can chop off the zeros and say we really have 150 divided by 6. So we're going to have 2 with a remainder of 30, right?
2.5.
So this is going to be 2 and a half.
Oh, that's not that bad.
Wait a minute.
It's 25 hours.
Really?
Because the decimal shift that we have to make, because the 0.
That's
Because it's not 15 divided by 6, it's 150 divided by 6.
pretty bad.
So guys, if you did this continuously, no bathroom breaks, no lunch breaks, no anything, it is literally all day.
Plus an hour.
Now, you could pull a Tom Sawyer, Huck Finn sort of situation to try to convince your friends to help you. Look at how fun this is. Don't you want to join me in polishing this sculpture?
No.
I'm having such a great time. You wish you were having this much fun. You guys know what I'm talking about, right? Are you literate? Have you read these great classics? So now, let's talk about if it's not a cube. Now we could, let's say we have a rectangular prism. So here's my cube, my rectangular prism. What sides are going to be identical here? What sides on this, or sorry, what faces on this will be identical? Nobody, Elena?
Well, like the long ones and then like the ones that I don't really know how to explain them, but like I know.
So the long ones, you mean like this?
Yeah.
So the front
Yeah.
would match which other face?
The back,
The back, and then
The
your
top.
left would match
the right,
the right, and then
the top and match.
the top would match the bottom. So in any prism, we have matching faces because how the dimensions are made. So we start to break up the different dimensions. We say, okay, what if I break my shape apart? There we go. Suction. It's vacuum. So if we ignore the top and the bottom, we're going to fold these away and ignore them for right now. And I look at my 4 rectangular faces, but when I unfold my 4 rectangular faces, what do I get?
4 rectangles.
Put them together.
A rectangle.
A rectangle. So when we unfold our prism, we really get a rectangle. So that lateral area, we can figure out by just calculating the perimeter of the base, how far is it around the shape, which actually ends up being this. So if you want to label this, that is actually your perimeter of the base. And this height is the distance between bases. So distance between bases. And that'll work on any prism. So if I bring you a pentagonal prism, a 5-sided, it does the same thing. Ignore the top and bottom faces. I unfold this. It's a big rectangle. This length is the perimeter around the pentagon. And this shape, this distance is between the 2 pentagons. So that'll work no matter what your prism is. Now, surface area for pyramids is obviously very different. But so then if we just talked about the the side faces. What faces didn't we talk about yet?
The top and bottom.
The top and bottom, right? So our formula, actually, if I was you, I'd write it out here, write it a little bit bigger. Our formula becomes that lateral area, this rectangle that was the sides around it, plus 2 times the base area. And we represent that with big B. We use capital because that is specifically saying the area of the base. Why don't we use little b? What might we end up using little b for? Not a variable. If I go to use a triangular prism and calculate the area of the triangle, the formula for area of a triangle, do you know it, Moon? I did not put this one up yet. It'll be up by today. As we get into things, I'm putting more and more posters up. But I have this cheat sheet kind of poster that tells you all the formulas for areas of your 2D geometric shapes. Area of a triangle, right here, 1/2 little b times little h. So little b represents the base of your triangle, not the base face, but just the distance of the base. So be careful, we gotta use big B here. That's worth pointing out that is super important. That's different, and we wouldn't necessarily be using that here, and you won't be using that here right now. Yeah.
Wait, so what is lateral area again?
It's the area all the way around. So we just looked at the lateral area right up here. So you probably want, that's a good question to point out, you probably want to highlight that formula right there. That lateral area is the perimeter of the base times the height of the prism, or distance between bases.
But here it just is the lateral area of the perimeter. What is
Perimeter of the base times height of the prism. So again, perimeter of the base, distance around whatever your base shape is, times the distance between your base shapes. So let's put this into practice. That's a highlight. So we have a cube. Obviously that's easier. The last formula I'm going to show you is an unnecessary formula. You don't need to know this, because this formula will work just fine, but if you know that your object is a cube, and we already did this, you know you've got 6 identical faces. You know that you can find the area of a square by that edge length squared. So if you know it's a cube, we can use this formula, that area of the whole thing, that's why we use SA for surface area, meaning the entire coverage, is 6 times that S squared being the area of one face. Even when I write sloppy calligraphy, ink just makes it look so much nicer. There's a pen setting on here if you haven't seen it. Sometimes it looks like a marker. This is when it looks like calligraphy. It gets wider and thinner. So we can use this nice simple formula on our cube down here. So let's go ahead and this 3 foot by 3 foot by 3 foot cube. Let's go ahead and solve that surface area using our cube formula. Really? Hey, gravity works. Heard you guys have some really good scores on gravity for our stems. So again, start always, guys, I'm telling you this and I will laugh at you and say I told you so. Sorry, not being rude, just enforcing I told you so. Start with the base formula, like the beginning formula. Don't put in any numbers. Don't try to start solving. Start with what am I going to use here? Okay, I'm going to use 6 times S squared. Then start plugging stuff in. So now I can say, all right, surface area, my edge length here, S is our edge length or side length. 3. What is it when I square a number? What's that actually doing, Sean?
Just timesing
Timesing by itself. So 3 times 3 is 9. My surface area becomes 6 times 9, which equals 54. Label? Feet squared. Any questions on how we calculated that? Now here's the problem with a prism, especially rectangular prisms. Because most other prisms, the base is obvious. They tell it to you in the name. Like, if I see a pentagonal prism, I'm not going to lay it like this and say that the rectangle is the base. That would be dumb. Because the pentagon is the base. It stands up like this, pentagon on bottom, pentagon on top. But when I look at a rectangular prism, what if I lay it down like this? Do I have a rectangle on bottom? If I flip it like this, do I have a rectangle on bottom? If I flip it like this, do I have a rectangle on bottom? Well, a square is a rectangle. Be careful. So, this rectangular prism over here, what's the base? We have options, and that makes things harder. So, determine your base before you start. I like to shade it. And it's easiest if we talk about the base as whatever's on the bottom. So, by my perspective, this is my base. So I'm going to go ahead and start by calculating my base area so that I don't forget about it. So my big B, capitalized please, is a rectangle composed of what lengths? 9 and 2. So 9 times 2, my big B is 18. And I'm going to circle that as a working number that I need to bring back and use again. I'm not done, but I'm going to need that number. It's important. That's why I notate. I circle, I highlight, I something. That number is important. I then set up my original formula. For a prism, it's a bit more in-depth. Probably start making sure we're all awake this morning. Somebody, I don't know if a sub screwed with my cards or what, but somebody put people back in the wrong classes. Sorry, because we moved some schedules around. So in Nish, when I go to calculate surface area of prisms, not cubes, what do I use? What formula? So I've already got that capital B, so let's just now calculate lateral area. So my lateral area setup is your perimeter times your height. To get that perimeter, we walk all the way around the base. So 9 doubled, 2 doubled. Well, 9 doubled is going to give me 18. We actually already figured that out. 2 doubled gives me 4 more. We get 22 times the distance between the bases is 3. Notice that I used all 3 numbers. I used the 9 and 2 in calculating the perimeter, and then I used the 3 since that's my distance between.
Why do you need the 3?
Because I am calculating the entire... So imagine that that is this. We have calculated this rectangle, and that will both be 18. So 18 up here, 18 down here. You good with me there? Now we need to calculate the back face, the side face, the front face, and the other side face. I can do all of those together if I add up all the distances around and then multiply by the height. Because I could do them individually if I did the front, 9 times 3. I did the side, 2 times 3. The back, 9 times 3. The side, 2 times 3. All of those added up. That looks like a not equals sign.
So the perimeter of the...
Would be 66. So that goes back, look up your sheet a tiny bit. The lateral area formula right here, and that breaks apart those 4 sides. It looks at all of them together. So that's why we're doing a shortcut method. So I need to change that color so it matches. So that lateral area becomes 66, and I need that as well. That's another important number to getting my final answer. So then I can put it all together and say surface area will be that 66 plus 2 times that 18. Any questions with how I set that up? Because I have 2 of those bases. Remember, our formula here uses 2. And actually, that's one of the most common mistakes. People put in the base, but they forget to double it. Jeremiah?
I don't really understand any of the second part of the essay. No, I know where 66 came from, but where did 2 times 18?
So 18 was the bottom that we calculated first that I shaded in red. And the bottom matches the top. So I have to double it to look at both of them.
Oh, okay.
Any other questions? And I can't like break this apart like I would want to, but that lateral area is this face, this face, this face, and the back one back here. But I can't cut this apart because I don't want to. Because like when we teach it like this makes sense. These guys are lateral area and these are your bases. But right now it's laid down like this with one of the rectangles as your bases. I mean, they're all rectangular faces. But when I add all those up, Ozzy, did you have that for me?
Oh, yeah.
Final answer?
102.
102 feet squared. I will put that in a box. Make sure that you label SA equals so that you know that is your final total surface area. Because we're working with lots of different numbers as we go through here. You've got to circle your final answer. If you don't somehow notate your final answer is your final answer, it's just a mess on your paper. And if it's if it's too frustrating to grid your paper, I'm just going to have you sit down with me and explain things to me. So please try to clearly communicate your final values. As you're doing your homework, you will waste your time if you don't write stuff down. You need paper, pencil out with you. You need to be writing down this process. There's too many numbers to remember. You will get confused. Your calculator's not good enough. So please trust me on that. Try this guy on your own. If we treat this face as our base, since it's on the bottom, and then that'll mean that this one will also be the base. We'll double for that.
There's so many formulas.
It's really just like manipulations of a couple. There's really only two formulas, but we start to combine them together. Try not to look up here, if at all possible. I'm going to start writing values and answers. By the way, if you don't like the lateral area formula, you don't have to use it. You can just calculate each individual face and add them all up. The lateral area formula is only a shortcut if you choose to use it. Four and a fifth, by the way, decimal conversion, 4.2. A fifth is 2/10. I think if you're done, give it a check and see if you agree with me or if I made a mistake anywhere.
You're good.
Oh, well, thank you.
I disagree.
Am I right, though?
Yeah.
So Ozzy disagrees. Did I make 6 lateral perimeter height? What do you think I screwed up? Because I think I'm right. You check your work.
Oh, wait a minute.
So this is essentially the minimum amount of work that I would expect to see. And on your mastery, you turn in just answers, I'm shredding it. Sorry. Like, that's how angry, like, you can't, like, I get it, guys. I'm not trying to challenge you. I get it. Some of you could do this mentally and with a calculator. But that's not the point. The point is getting used to a procedure of I'm going to calculate this, jot it down, I'm going to calculate this, jot it down, I'm going to work with all these numbers and put them all together. I'm not joking. You turn in just answers, I'm destroying your test and you're starting over. Sam.
Okay, so for the lateral perimeter, how did you get 10?
So the distance around my bottom here that I had shaded red, 3 plus 2 gives me 5, plus 3 plus another 2 gives me 10, then the distance between. So now you can imagine this is like this prism, right? So my bases are the 3 by 2. Each of these is 6, together 12. So then I can ignore those, and then I look at just this big rectangle. This was 3, that was 2. This was 3, that was 2. Together, they're 10, and then the height is 4.2.
Okay, that makes sense.
If you're confused at all, especially while you're doing your homework, you can come up and play with these. I just need them during class so I can reference them. Sorry, dude. I was a little short with you earlier, but like I just got. What are you doing? Just taking my stuff.
Well, I remember last class or one other class you were like, I thought you said something.
You guys can come up and play with these and stuff, but like outside of class, like AO and whatever, come mess with them. And you can draw on them with like dry erase markers if you're trying to like as we get deeper and like how do I calculate a pentagon area? Well, really we break it up into triangles. So we've got different things we can do with these, and we will as we go deeper. Give you a minute to try this. Let's see what happens when you're rushed. If you haven't done the fourth one yet, you have 1 minute. And I would encourage you, don't use our formulas.
I didn't expect us to do it.
Try a different method.
Nope. Nope.
Alright,
I'm that's fine. How do you do it without doing any? How do you create any? Wait, so are you saying we like calculate each individual side and add them all up?
Not each individual side, though.
I mean, you would find the face, like the front, and then multiply by 2 and find the front and back.
And that was under 60 seconds. But let's talk about another way we can do this without using that lateral area formula. We already talked about pairs of faces. We already know that my base is doubled because it's the same on top and bottom. So if I look at the base here, and guys, all these numbers are easy to work with. I have a base of 6, and then if I double it, both of them together give me 12. If I look at the front or the back, I have a height of 9 and the width of 6. So if I say front is 9 times 6, that's 54. I have 2 of those. That's 108. If I look at the left and right, what are the dimensions of those? 9 and 1. So that times 2. Sorry, I should have 9 times 2 right here. Crap, I should be doing that in green. Sorry, I like my color coding, kind of OCD. And if we then add all these up, what do we get, Jeremiah? Okay. 1 what? Did you have a question?
I mean, yeah, I said
138.
138.
138.
Yeah, 8 makes 16 plus 2 more. We should be ending in an 8. Crap, colors, whatever. My colors aren't going to match. Questions. We know the pairs of faces. So if you forget the formulas or just don't want to use them, you don't have to. Jeremiah.
Why is B 6 times 2?
So the base was 6. Then I doubled it because I have 2 of them. So all of these,
On all the other ones, you just.
no, on all of these operate, like, we're not using the other formulas. We're ignoring those other formulas and just pairing up faces. So I pair it up. My bottom will be the same as my top, solve my bottom, then double it. My front will be the same as my back, solve my front, double it. My left will be the same as my right, solve it, double it. Does that make sense now? So this doubling was not to calculate the base. That was doubling the base because there's 2 of them. So 2b compensates for that you have both bases. Yeah. So this was our 2 times b, essentially, and 2 times the front, and 2 times the right. Let's skip the cube one. We can probably do that. It's just trying to get you to see that when fractions multiply by each other, they get smaller. We need to keep moving because really I've taken too long on some of this stuff. And I never want to move faster than you guys can handle, so it's okay. I just expected we'd be moving faster. The name of the prism tells you the base. So, in the Netherlands, Misadventure tasted some Dutch cheese. So, our base has been told to us as the triangle. So this is where we have to use our other geometric formulas, the area formula for a triangle. So here our base will be calculated by 1/2 little b times little h. Now this is dangerous because little b is the base edge of your triangle and little h is how tall is your triangle. Because if you take a triangle and you had cut it in half, this half can drag, flip, and pair on the other side and make a rectangle. So like base times height makes a rectangle, but it's only half that. Triangles are half rectangles. So you should have seen this formula in 6th grade at least a little bit, but a triangle is half of a rectangle, or if you draw out a rectangle and think about the triangle is half of it, this makes sense. That area will be half the base times height because this is also half the base times height. And that applies to any triangle. So together, the whole thing is base times height. Each part is half base times height. It was not manipulatable enough. I could not do enough tweaks.
But Mr. Hassan, do we really have to do the half times base times height? Can we just do base times height because there are two of them?
Yeah, but if that works for you, that's fine. I'm not shortcutting like that for the whole class because that confuses people. Because then they start thinking, wait, why aren't we doubling the base? Well, we did, but we didn't talk about it. That confuses people. So we do 1/2 the base of our triangle here, that 10 centimeters across, the height of our triangle here, that 14.1. To get the height, it has to be, guys, can we stop drawing each other? Come on, we're in math class. Like, do I need to not let you sit back there? I'm giving you a lot of freedom. So don't curl up, like, get your pencil back out. We're writing more notes. We're actively solving a problem. Come on, it's really disrespectful. I give you guys a lot of trust to be able to sit back there on the floor and do whatever you want. And that's not on task behavior.
Good morning, Carolyn Putnam. Putnam, please come to the office. Carolyn Putnam, please come to the office.
I'm going to do this first because it's easier. 14.1 times 10 is going to be 141. Then I cut that in half, and I'll get 70 and a half. Or 70.5, depending on how you want to work with the numbers. Then, this is where life is really easy using that formula. I could calculate this rectangle on the front, and then that rectangle back there, whatever I call it, and then that rectangle on the side. But guys, I don't have any pairs of rectangles here. I don't have a front back that are identical, or a left right that are identical. I have 3 side faces now. So imagine it like this. These rectangles are not identical because I don't know what these lengths are. So that's where that formula, well, I do know those lengths. They're each 15 because it tells me 15, 15. So I could calculate each of them and then add them up. Or use your formula and just say lateral area is going to equal perimeter times height. Try to fill in those values on your own. What's up, Julie?
How did you find little b again?
It is the base edge of the triangle, which is given to us right here. So the base and the height are going to be perpendicular to each other.
Should we be taking as a base?
So this that we colored green, that's our base. We were told it's a triangular prism. So to find the perimeter around our base, we have to walk all the way around here. Well, this is 15, this is 15, and this is 10. So our perimeter is 40. Our height, or the distance between the bases, is 6.5. I will probably actually break your guys' homework apart. I didn't make it live yet, so I'll just give you guys homework on 13.1 for just surface area. 15, 15, and 10. You're missing your other 10. So I might as well write this out. Our perimeter comes from the crap. I want green. It's the 15 plus the 15 plus the 10, then times the 6.5. That then,
260.
thank you, 40 times 6.5. We don't have to put units on until the end. You got my final answer, Julian? Got my final answer? Why are you talking to Sean? Okay, what's up? What's up? Other people might benefit from it. Okay, what was your question to him? What was your misunderstanding is what I'm trying to figure out. Because if you have misunderstanding, other people probably do as well. But what was it? Because I think you're lying to me and you were actually talking about off-task crap. Guys, we're in February. This behavior doesn't fly anymore. We're prepping you for 8th grade. I'm going to be on you. Pay attention. When we're moving slower than I want to and people are off-task, it's really frustrating because you're in the accelerated class. Either get on task or get out. Sorry. Love you guys, but we got to do work in here. So this is our lateral area. That's our base. We got to put them together. Say my surface area is going to combine all that, my 260 plus double, this is what most people forget, my 70.5. Now Manasa asked me, why do we cut this in half to then just double it? And yeah, you could shortcut and not cut it in half and not double it, but you're going to eventually make a mistake because you did that. I'm not saying that's the end of the world, but if you take these shortcuts, you're probably going to eventually make mistakes because of some slight misunderstanding of what you're doing. This is the area of the triangle. We have 2 of them. This is the area of all 3 rectangles around. When we compute this and add it all together, this becomes 141 again, added to the 260, and we get,
401.
yeah, I believe it's 401, right?
Yeah, 401 centimeters squared.
Box it, something, and I do not have surface area equal, so I would label that somewhere that that's your final surface area. Okay, we're not done. I got 4 minutes left. Yeah, who told you were done? Did you look at the clock? Did you look at the schedule? Let's stop inferring and assuming. Try this on your own. Pay attention that your base is a triangle. So your base is not the bottom. It is not sitting on its base right now. This makes it harder for you. The base doesn't mean bottom. The base means what shape is cloned on the other end. Because guys, all I would have to do to this is stand it up. It's 3D. I can do whatever I want in the 3D world. So I can flip things up. So visually, imagine that you stood this up on that triangle. So that base area of big B, please again try to be doing this on your own, but if you need to look up here, you can.
6.
Because it's a triangle. Triangles are half of rectangles, so we use the half. So we get 6 for our big B, but that's only one of them. Now stick with me. I got time. They released early, so sorry that they released early, but I'm trying to make sure we understand this for our homework. This distance around the triangle is what I care about for perimeter. So 3 plus 4 plus 5, that gives me 12. So my lateral area becomes 12 times the distance between the bases, which is this 7. Be careful, that 5 looks like it might be the other. This is 7, the distance between your bases. Bless you. This becomes 84. So my final surface area, and we're going to have to pick this up with hexagons tomorrow, which is really sad that we moved this slow, guys. We've got to move faster tomorrow. Like, we got to get in here on time and get down to business. And I need to stop wasting time correcting behavior. And we should get 96 meters squared, I believe. We'll pick this up with hexagons tomorrow, but I will warn you, there are going to be hexagons on your homework. Give it a shot. You don't have to submit it yet. Remember, Chapter 12 is your high priority to get that done and submitted.